Biometric authentication is the process of using a unique physical or behavioral trait to confirm an individual's identity. This authentication method determines the access profile of a person. There are two types of biometric authentication: physiological and behavioral. Physiological is based on a unique physical trait such as palm print or DNA, while behavioral uses common characteristics of a person such as walking gait or speaking rhythm.
Have passwords outlived their usefulness? Here are some weak passwords exposed in website breaches this year, ranking from 1 to 20. You can see the obviousness of most of these passwords. Passwords are potentially the weakest link in your organization's information security systems. Security vulnerabilities can be minimized by using complex passwords, but such enforcement comes at the risk of employees writing these passwords down, thereby defeating an attempt to increase security. Biometric authentication technologies promise to ensure a more secure alternative because they are based on a unique individual biologic characteristics.
Face recognition. Every face has distinguishable landmarks defined by peaks and valleys called nodal points. Facial scans use approximately 80 nodal points to map and compare against a stored reference image in a database.
Human odor or scent is another biometric giveaway. Depending on an individual's diet, natural odor, environment, or cosmetic factors, each individual has a different scent. Scent is based on capturing volatile chemicals emitted by skin pores. There are recognizable patterns for each person's body odor that remain steady over time. The accuracy rate of identifying a person by their unique odor is higher than 85%.
Ear shape, the identification of an individual based on the shape of their ear. The ear structure remains the same over time, and this method must be used in conjunction with another biometric authentication.
Retina recognition is another biometric form of security. Retinal scanning is performed by casting an unperceived beam of low energy infrared light into a person's eye as they look through a scanner's eyepiece. The beam of light traces a standardized path on the retina. Because the retina blood vessels are more absorbent of this light than the rest of the eye, the amount of reflection varies during the scan. The pattern of variations is converted to computer code and stored in a database. Identity rate error for retina scans is estimated to be only 1 in every million.
Fingerprint hand geometry uses 3D geometry of the hand or finger to determine identity. They do this by examining the spatial geometry as the user puts his hand on the sensor surface and uses the guide poles between the fingers to properly place the hand and initiate the reading. Because the hand and finger geometry have a low degree of distinctiveness, the technology is not well suited for identification purposes.
Iris scanners read from the outer edge of the iris toward the pupil, detecting and plotting unique data points. This data is saved within a chip on an ID card or a passport for future reference. The eye tissue pattern has a unique pattern of markings that will not change and is different for each eye.
Fingerprint recognition uses the distinguishing features found on the tips of the finger. The corrugated surface of the skin form a pattern that can be stored and compared against the fingerprints in the future. A disadvantage is that any physical altercation to the fingerprint could affect the ability of the fingerprint scanner to read accurately.
A speaker's voice is extremely difficult to forge for biometric comparison purposes. Complexity derives from the dialect, speaking style, and pitch, to highs and lows in voice frequency. The vibration of the user's vocal cords and the patterns created by physical components resulting in human speech are as distinctive as fingerprints.
Gait analysis is the study of how a person walks. How a person walks is complex. The gait may change over time due to injury, weight changes, or temporary behavior changes affecting movement, and is not overly differentiating between individuals. The verification it takes into account is speed, cadence, step length, and width, or the different angles and articulations. It can be monitored remotely, and video samples are inexpensive to obtain.
Vein recognition is another form of biometric security. The vein scanner works by using a camera that takes pictures using near-infrared light. The hemoglobin in your blood absorbs the light, so the veins will appear black in the picture. The software creates a reference template based on the shape and location of the vein structure. Veins are extremely difficult to counterfeit or tamper with.
Handwriting recognition. It analyzes the handwriting style of the individual, particularly the signature. It analyzes the letter shape, the speed and rhythm, and the sequence and how letters are formed. For example, do you add dots and crosses as you go or after a word is finished?
So how do biometric identification systems stack up? When it comes to accuracy, voice and face recognition systems still have a way to go. In terms of security, the degree to which identification systems can be fooled by a copy, photograph, or recording, vein and iris biometric systems perform the best.